The Chatelier's principle demonstrated through a tea study. First off, you will want to make sure that you have your black tea indicator and your stressors that include ammonia, lemon juice, 6 molar sodium hydroxide, baking soda, white vinegar, and all glassware that will be needed for this experiment, and that it has all been properly cleaned and dried before use. Next, you will get the 800 milliliter beaker and fill it with about 450 milliliters of distilled water, and using a glass thermometer, you will determine the temperature of the water at room temperature. Next, you will place the 800 milliliter beaker with the water onto a hot plate, then wait for the water to start boiling. To speed up the process, you may place a large watch glass over the beaker. Once the water starts to boil, continuously steep 1 tea bag into the boiling water. The tea should become a bright orange color after about 2 to 3 minutes. Then we will remove the 800 milliliter beaker with our newly created tea solution and let the solution cool down to room temperature that was previously recorded. When transferring the beaker from the hot plate into the ice bath, be sure not to touch the hot beaker directly to avoid burns. Next, you confirm that it has reached room temperature that was previously measured with a glass thermometer. You will need to repeat the previous steps to create more of the tea solution. The time in which it takes for your tea solution to cool can vary from 25 minutes to an hour. Once the tea solution has returned to room temperature as measured before, we will get 9 250 milliliter beakers and label them as follows: control, white vinegar, lemon, concentrated, and sodium hydroxide, ammonia, baking soda, plus heat, and minus heat. Then we will fill each beaker with 100 milliliter of the black tea solution that was made earlier. Once all of our beakers are labeled properly and filled to about 100 milliliters, we begin to add our stressors. We place an additional tea bag into the concentrated beaker. When adding the additional tea bag, as opposed to only steeping it, we did utilize a stirring glass rod to ensure that we got the most visual color change possible. We measure 22 milliliters of white vinegar using a graduated cylinder and then place it into the white vinegar beaker. We also measure 22 milliliters of 6 molar sodium hydroxide using a graduated cylinder and pour it into the sodium hydroxide beaker. After that, we cut a lemon in half and then squeezed half of the lemon into a beaker labeled lemon. Then we moved on to measure approximately 5 grams of baking soda and added it to the beaker labeled baking soda. And when adding baking soda to our tea solution, it is important to remember to use a stirring rod to thoroughly dissolve the baking soda entirely into our solution. Using a graduated cylinder, we then added 25 milliliters of household ammonia into the beaker labeled ammonia. Once you have added each of the corresponding stressors, compare the color of each beaker to the control. Record any color differences that you observe, and do not dispose of your samples. For the plus heat beaker, you will begin by placing the beaker onto a hot plate and letting it heat up to about 100 degrees Celsius. Confirm the temperature using a glass thermometer and remove it from the hot plate and immediately compare it to the control. For the heat removed beaker, you will be placing the beaker into an ice bath to cool down the tea solution, to ensure that the ice bath contains salt to speed up the cooling process. Place the heat removed beaker into the ice bath and wait for the solution to cool down to around or below 0 to 5 degrees Celsius. This process may take 25 minutes to an hour to witness any noticeable color change. Once the solution has cooled down to our desired temperature of around or below 0 to 5 degrees Celsius, remove the beaker from the ice bath and compare it to the control. Record any differences in color between cooled tea sample and control. Once observations are complete and recorded, excluding heat added and heat removed, pour all samples into cuvettes, then use a spectrophotometer to determine the transmittance of each sample from 400 nanometer to 560 nanometer. The mist from the heat added and the condensation from the heat removed will affect the spectrophotometer, so it is not feasible to test the transmittance of these two samples. Lastly, you will calculate the absorbance from the transmittance using the equation A equals log 100 divided by percent transmittance. Then you will generate a scatter plot that displays the relationship between wavelength and the absorbance of each sample.